So let's try to find the centroid of the area bounded by the curve 2y squared plus 2y minus x minus 2 is equals to 0 and the line x equals to 2. So the first thing that you need to do is to get the vertex and other details of our graph. So let's start with our curve. So you have 2y squared plus 2y minus x minus 2 is equals to 0. So we need to get the vertex from here. So if I will factor out 2 from here, from these two terms, I have 2y squared plus 2y, plus y, right, plus y quantity. Then I will transpose these two terms to the other side, so I get x plus 2. So I need to complete the square so that I could get the vertex. So you have 2 times y squared plus 1. What should I add and what should I subtract to get the perfect, to complete the square of this equation? So maybe I will plus 1/4, alright, which this is equal to y plus 1 half quantity squared, alright? So if I added 2 all over 4, which is 1/2, I need to subtract 2 all over 4, which is 1/2. So we'll just write it here, 1/2. So I add 2 all over 4, 1/2, then I'll subtract 1/2. It's still the same. The equation is still the same. So this is equal to x plus 2. So now I will have 2 times y squared plus y plus 1/4, right? Then transpose 1/2 to the other side. So I have x plus 2 plus 1/2, which this is equal to 5/2. So I'll just write 5/2 here. 5/2. Then divide both sides by 2, right? So y squared plus y plus 1 is equal to y plus 1/2 quantity square, right? That's the factors of this. This is equal to x plus 5. Alright, I'll just get the LCD na lang, which the LCD is 2. So this is 2, right? 2x plus 5 all over 2. Now, the vertex at y plus 1/2 is equal to 0. This is y equals to 1/2, negative 1/2, right? So we have 2x plus 5 all over 2 is equals to 0. So this is equal to 2x plus 5 is equals to 0, and x is equal to negative 5 all over 2. So therefore, our vertex are negative 1/2. That's for the value of y. So let's write the x first. Negative 5/2, then negative 1/2. Right? This is our vertex. Now let's get the intersection points for both, um, for the curve and line. So at x equals to 2y, what is the value of y? Right? Equated sa ato ang curve. So we have 2y squared plus 2y minus 2y, right? Which is this one, x, the value of x is 2y, minus 2 equals to 0. So this becomes 0. You have 2y squared minus 2y equals to 0 ang nabilin. Transpose 2 to the other side. So you have 2y squared is equal to 2. Then divided by 2. Then y squared is equal to 1. So get the roots of both sides. So our y is equal to positive negative 1. So we need to get the value of x. So at y is equal to 1, what is the value of x? So you have 2 times 1 squared plus 2 times 1 minus x minus 2 is equals to 0. Just input this in your calculator and get the value of x. So x is equal to 2. So one of our intersection points is 2, 1. So at, so POI. So this is intersection points. So point of intersection at y is equal to negative 1. That's 2 times negative 1 squared plus 2 times negative 1 minus x minus 2 is equals to 0. Just input this in your calculator and then you will get negative 2 for the value of y. So therefore, another intersection point which is negative 1 then negative 2. So we already have the details of our graph, so we could plot it in our Cartesian plane. Now with those details about our graph, we could graph it na. So let's say that this is our Cartesian plane. This is x-axis and the y-axis. So this is 1, 2, this is 1, this is 1, 2, this is negative, oh, this is negative 1, negative 2, then this is negative 1, this is negative 2, this is negative 3. Alright? So now, our vertex was located from negative 5 halves, then negative 1 half. So, if negative 5 halves, that's negative 2.5, it's around here. So, it's around here at the vertex. This is negative 1 half. So, this is the vertex, right? So, let's write vertex is negative 5 halves, negative 1 half, right? That's the vertex. Now, we solve for the intersection points. So, which the intersection points are, um, that was 2, 1, and negative 2, negative 1. So, we have 2, 1 here, right? 2, then 1 here. So, this is the itura of our curve. It looks like this one. Which, this intersection points with the line or slant line that we have that passes through the origin, right? Because according to your basic geometry, x equals to x, y, you could form a slant line, right? That passes through the origin, yung line. So let's say that this is a perfect slant line, which this is equal to x equals to 2y, right? And the curve, which it is, or it has an equation of y, 2y squared minus, plus y, plus 2y, sorry, 2y squared plus 2y minus x minus 2 equals to 0, right? So to get the centroid, you need to get the area first. So the area here, we are not allowed to make use of the um vertical strip, but we will use the horizontal strip. So we will write the strip here. We'll just write it here. So let's say that this is our strip, right? This is dy. So to get this length, that's x right minus x left. So let's get the area first before we will move on getting the centroid. So area can be solved from this given output that we have for our in our graph. That's area is equal to the integration of x right minus x left, right? X right minus x left times dy from your lower limit here, right, to the upper limit, which is here. So from A to B, right? So area now, let's substitute the values that we have. We have our x right, which is the line. So x2 is equal to 2y. So we have 2y minus x left, which is the curve. So we need to isolate for the value of x here. So you have 2y squared plus 2y minus 2 is equal to x. So this is the equation for our x left. So this is equal to quantity of 2y squared plus 2y minus 2, right? Quantity times dy from our lower limit, which is um, we say that this one here is negative 2, negative 1, and this one here is 2, 1. That's our intersection point. So from negative 1 to 1. So you have negative 1 to 1. Take note that we are in dy, so our parameters should be in y value, right? Because there's a change in terms of y, length y. Alright, so we could evaluate this equation, right, or this integrand here. So we will have integration from negative 1 to 1, 2y minus 2y squared minus 2y, right, plus 2 times quantity dy. So this one here and this one will be cancelled out. So you have area is equal to the integration from negative 1 to 1, negative 2y squared plus 2 quantity dy. So we will have to evaluate this. So this is area is equal to integration of, maybe we will evaluate immediately. So this is equal now to negative 2y raised to 3 all over 3 plus 2y from negative 1 to 1. So substitute the upper limit minus the lower limit is substitute sa given equation here. So you have negative 2 times y raised to 3 all over 3 plus 2 times 1, right? Quantity minus the quantity of negative 2 times negative 1 cube all over 3, right? Plus 2 times negative 1 quantity. So just input this equation to your calculator, and then the value of the area is equal to, which is 8 all over 3. That's the area of this bounded region, square units. So we already have the area. Now we could solve for the centroid. So I'll just move it to the... So now let's try to get the x bar. So x bar is solved by integration of x times dA all from a to b all over a. So if we will go back to our curve, so in the line, so let's say I have the line here, right? It's perfect, same detail. I will not write all the details, but the the curve itself is similar to our drawing kanina. So let's say that this is the curve, right? So we have our dx here, sorry, dy here. So this is our strip. This part of the curve, then this part of the graph, right? This is the length of our strip. This is equal to x right minus x left, right? So we are going to get the midpoint. So if this is the strip, our midpoint is somewhere here, right? So to get this length from the strip, from this part of the strip to this part, right? This is equal to the part. I'll just write it in another color of the pen, of my pen. So this one here is equal to x right minus x left all over 2, right? To get this length here, right? Take note that this part belongs to the negative x-axis, right? So negative part of the x-axis. So therefore, this whole length here is negative quantity x right minus x left all over 2. So kani ang atong i-transpose sa atong x value. Instead of x, we need to write it this way, right? Take note because we are in change of y, and based on the figure that it is not just simply x, but this is equal to x right minus x left all over 2. So now you could write x bar is equal to the integration of x, which is x right minus x left all over 2, right? That's a negative 1 because it's belong to negative axis of x. Alright, negative x-axis times dA, which is our dA was um, the equation of getting the area, which is x right minus x left times dy from same parameters a to b, which it was negative 1 to 1, right? All over a. So we could substitute the values that we have, right? Now, integration, the x bar is equal to the integration of x right minus x left. I think we simplified this equation that was equal to negative 2y squared plus 2, right? Quantity times negative ito kasi negative all over 2 times similar yung x right and x left. We just simply copy it. Negative 2y plus 2y squared plus 2 times dy, right? From negative 1 to 1. So, all over a. So, we could factor out a. So, wait lang. A is equal to 8 all over 3. That's the area that we solve for this given area here in the figure. So, we could factor out the constant value. So, we will have to factor out negative sign, negative 1 half, right? Times 3/8. That's negative 3 all over 16. Integration of we can expand this na lang. So that is equal to 4y squared minus 8y, 4y to the fourth minus 8y to the second power plus 4 quantity dy from negative 1 to 1. So we have x bar is equal to negative 3 all over 16, right? Then let's try to evaluate this na lang. 4y to the fifth all over 5 minus 8y to the cube all over 3 plus 4y from negative 1 to 1. Let's substitute the values. We have x bar is equal to negative 3 all over 16. Our upper value is 1, so we substitute it sa ato equation. 4 times 1 raised to the fifth all over 5 minus 8 times 1 raised to 3 all over 3 plus 4 times 1, right? Minus the negative 3 all over 16 times our lower limit, which is negative 1. So you have 4 times negative 1 raised to the fifth all over 5 minus 8 times negative 1 raised to 3 all over 3 plus 4 times negative 1. Sorry, that's negative 1. Negative 1. So this is now equal to, or x bar, just input this in your calculator, you will get, this is equal to negative 4/5. So therefore, our x bar is located at negative 4/5. It's around negative 0.8. So if this is our vertex, the vertex was, kanina, that was negative 1/5 and negative 1/2, and then our x bar is around negative 8, 0.8. So it's around here. So this is 1. For example, this is 1, so it's around here. So our centered is around here, right? Now we are going to solve for the value of y bar. So this is 2.5. Right. Okay, it's okay that it's here around here. Okay. Now y bar. Now let's solve for the y bar. Y bar is equal to the integration of y times dA from a to b all over a. So if we will have our curve again, I will draw it again kasi I don't have any access to the previous one. So this is our curve. Imagine that that's the vertex and the line um, here. Let's imagine that this was the line, right? Which is, this is equal to x is equal to 2y, and then this one here is equal to 2y squared plus 2y minus x minus 2 equals to 0. So now let's have our strip. Let's assume, we're just assuming that our strip is located somewhere here, right? Then the vertex is somewhere here. Let's assume it's somewhere here, right? So the distance from this part, which is the x-axis, to the centroid, let's assume that this is negative y, right? So from this point to this point here is negative y. So with that, we could solve for the y bar. Y bar is equal to the integration of your y, which is, let's assume that it is negative y because it's located below, or the third quadrant, which both x and y numbers or values are negative. So negative y times dA, that was negative 2y squared plus 2 times dy. We just simplified it all over, because dA was x right minus x left, so we just simplified it from negative 1 to 1 all over 8 all over 3, so which is our area. So now we could solve for the x bar. We have negative 3 all over 8 integration of y. Distribute lang natin sa each term. So you have negative 2y cubed plus 2y. It will be minus 2y. We already extract negative to the integration element. It will be 2y plus 2y times dy from negative 1 to 1. So we have y bar is equal to negative 3 all over 8 times negative 2y to the fourth all over 4 plus 2y squared all over 2 from negative 1 to 1. So cancel out to. Also here, this becomes, instead of 4, it will becomes 2. So we have y bar is equal to negative 3 all over 8. Right? Substitute the upper limit. So we have 1 raised to the fourth all over 2. That's negative quantity 1, quantity raised to the fourth all over 2 plus 1 squared minus quantity of negative 3 all over 8, right, times negative negative times the quantity of negative 1 raised to the fourth all over 2 plus negative 1 squared. So input this in your calculator. Y bar is equals to 0. Therefore, our centroid is at um, negative 4 over 5. That was the x bar. Negative 4 over 5, then 0. So it's because in our figure, we just simply assume, right? So therefore, our centroid is located somewhere here. Right, somewhere here. It's around here. So it's at negative 4, 5 over 5, then 0.